All right, my fellow Euclidean geometrists, we are going to go through section 3-2 in your geometry textbook, the Geometry Concepts and Applications from Glencoe Mathematics. 3-2 is about angle measures. In this particular section, there's some use with a protractor. I would like to make a separate video on the use of that protractor, but we can discuss as we go through this section how a protractor would work. More importantly, what I'd like to do is discuss angles and their measure, how you would indicate those measures in print or in Braille, and then identifying different kinds of angles. We're going to learn some new vocabulary in regards to what kind of angles you may encounter, and then you can answer some questions about them based upon that information. So we are on page 96 in print and 96 straight up in your Braille. It starts out with what you'll learn. You'll learn to measure, draw, and classify angles. And again, we'll do the measuring and drawing in a separate unit using our large print and Braille protractors and Draftsman. But we'll get through this section and kind of talk through it just so you can be able to do some of the problems in classifying the angles and identifying their measures. So it starts out in geometry. Angles are measured in units called degrees. The symbol for degree is a little in print. It's a little teeny tiny 0 that's superscripted up next to our number, very teeny tiny O or 0. In Braille, it says here on your Braille copy, it's going to be the superscript symbol and then a dot 4616, superscript symbol dot 4616, and that indicates the little teeny tiny 0 that you see next to the number. In print, for print users, I'll write that out. If we were to say 75 degrees, write the number 75 and then a little teeny tiny O or 0 superscripted up next to the 5. On page 96A in Braille, it discusses the angle shown measures 75 degrees. In the notation, there is no degree symbol with 75 because the measure of the angle is a real number with no unit of measure. This is summarized in the following postulate. So what they're explaining here is if you look at your drawing, so there's a tactile on page A96 where we have two rays. We have a vertex Q. Find out about the 9 o'clock position. If you go from vertex Q immediately right through point R through 3 o'clock, you have ray QR. Go back to Q, your vertex Q, and go up to about the 1 o'clock position, and you'll go through point P. So we have ray QP. And those two rays have come together at the endpoint, the common endpoint Q, created an angle, PQR or RQP. You learned that in the last section. We could also call this angle Q. And in the midst, in the interior of the angle, they're labeling the degree measure. They're saying it's 75 degrees. So number sign 75, dots 4, 5, and then a dot 1, 6, and then, or excuse me, 4, 6, 1, 6, okay, for your degree measure. It's showing below, there we go, I believe it is below, giving that paragraph of information. It doesn't show right below, let's see, measure, okay, it does. The very first line of the paragraph of information, it says measure of angle PQR equals 75. So notice there's a little m before your angle indicator, ED and OW, and then capital P, capital Q, capital R equals 75. And they're reminding you that if you write that out in print or Braille, you don't use the little degree symbol because you're already indicating with the little m that it's the measure of. So it's just assumed that that's going to be degrees. So print users, you do little m and your angle symbol, and capital P, Q, R, remembering that Q has to come in the middle between P and R because it's the vertex, and equals 75. And there's no degree indicator. But within the interior of the angle, where it says 75, they put the degree indicator. So that's good. It's stuff to pay attention to recognize as far as kind of the math grammar is concerned about how we use our code, our symbols. Postulate 3-1 is discussed, let's see, postulate 3-1 is on the next Braille page, Braille users B96. Print users were looking at the box with the blue to the left of it that says postulate 3-1 angles measure postulate. In words, it states for every angle there's a unique positive number between 0 and 180 called the degree measure of the angle. Angles are positive measures, just as distance on your number line is positive. It gives a model with an angle ABC or CBA and shows n degrees in the interior. And in symbols, it's showing little m, angle symbol, capital A, B, C equals n, and that n has to be greater than 0 and less than 180 to be an angle. If it's 180, it's just a line. It's a flat line. It's a straight angle. To be 0 is just it's just a point. There's nothing going on there. It also indicates that in this text, the term degree measure will be used in all appropriate theorems and postulates. Elsewhere, we will refer to the degree measure of an angle as just measure. And the tactile, hopefully it's very nice tactile on page B96, vertex B. Go from vertex B through, vertex B is on the left. Go through vertex B to about the 2 o'clock position and you're through point A. So you have that side, B, ray BA. And then ray BC is on the bottom, going through about the 4 o'clock position, and that's a side. You learned these terms in the last section. Vertex C, or B, excuse me, and then it says n degrees in the middle of it because it can show any positive measure between 0 and 180. Then it discusses further about how to use a protractor, and again, we're going to practice that in kind of a later supplemental video where I'll get those out and we'll do a practice with protractors. So I'd like to jump forward to page 97. I believe it will be 97. Uh-oh, did they skip one in between? Oh no, we're still going. Okay, 90. Maybe 97B. There we go. B97. And print users, you're right in the middle of section page 97. It's just reminding us, studying another postulate. It's called the protractor postulate. It says on a plane given ray AB and a number R between 0 and 180, there is exactly one ray with endpoint A extending on each side of ray AB, such that the degree measure of the angle formed is R. It's just, again, being very clear about our definitions, our theorems, our postulates, these statements, so that we can do things. And so this is reminding us that we can measure angles and get these measurements between 0 and 180. They also then discuss in a couple examples how to draw an angle, and again, we'll do that. We'll get out our draftsman and our protractor at a later time and practice doing that. So then I'd like to turn to page 98, where we want to discuss types of angles. And some of these terms probably sound familiar from your pre-algebra and algebra days. 98 is a page break on 97D in Braille. And it's just a section on types of angles. It gives some graphics to take a look at these. It says, once the measure of an angle is known, the angle can be classified as one of three types of angles. These types are defined in relation to a right angle. A right angle is a 90-degree angle. And if you turn the page, Braille users, to 98A, they have a huge tactile that indicates a right angle. It's over kind of towards the right-hand side of your page appropriately. There's a vertex A. They have a little square coming off of the vertex A between the two sides. There's a side that goes up through 12 o'clock and then a side that goes through 3 o'clock. And that little square indicates that this is a right angle. It's 90 degrees. In print, sometimes it's difficult to see. They typically will use a little red square, a little thin red line square to indicate 90 degrees. You have to look very closely and find that. So that's a right angle. The measurement of angle A is 90. So in relationship to this right angle, we name two other kinds of angles. The next one on the next Braille page, B98, is an acute angle. So they show this by showing kind of this ghost of your left side of your right angle. They kind of have just these dashes with some blanks missing in between them, and it's very faint. And then they have the little right angle indicator in between the bottom of that side. And then they have a line going through at an angle diagonally from point A, vertex A, through about 2 o'clock position, and that's a little heavier dotted line and tactile. That's showing that the angle is inside of 90 degrees or less than 90 degrees, and those are called acute angles. Acute angles are less than 90 degrees. And how I remember that is that they're cute little angles. Cute little angles are always less than 90 degrees. They have to be greater than 0 and less than 90. Then the next type of angles would be the ones that are greater than 90 degrees. So Braille users, if you turn the page to C98, again, they'll have a tactile with kind of the ghost side on the left there, going straight up and down of the right angle, and the little right angle square. And then they have two rays, one going to the right through 3 o'clock and then one going through about 10 o'clock. And that's showing that this is going beyond that right angle position. So it's bigger than 90 degrees. And anything larger than 90 degrees but less than 180 is an obtuse angle. And how you can remember that is it's obese. It's obtuse. It's greater than, fatter than 90 degrees. So you have a right angle, acute angle, and obtuse angle. And what you need to do is determine, just by looking at angles, you can label them by this, whether they're right, acute, or obtuse. And in the next example, example 4, 5, 6, we practice that. So on page D98, and print users, you're in the middle of your page on 98. We have examples 4, 5, 6. Example 4 shows two rays, one pitched, has a vertex up in the top right, and then it extends to the left through the 9 o'clock position, and then from that vertex extends down to about the 5 o'clock position. It's creating an angle that's bigger than 90 degrees. And it even tells you, admits the interior of the angle. You learned about interior and exteriors of the angles in the last section. Admits the interior of the angles, it's 110 degrees. So you should immediately know, okay, bigger than 90, this is an obtuse angle. So we would label it obtuse. The next tactile, the next drawing, shows two rays. It's on page E98. Two rays. Your end point, your vertex, is kind of the bottom right of these particular rays. You have a ray extending immediately to the left through 9 o'clock and then immediately up through 12 o'clock. And you have that little square indicating there in the vertex in the interior. That's indicating that it's a right angle. It's a 90-degree angle. They also tell you the measurement, which they don't often do. If they put that little square in, you have to know the code means that that's 90 degrees. They say 90 degrees, so you know, bing, 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 that's a right angle. And then finally, the next example at the top of, looks like, what do we have here, 6, or F98, listen to me name 6, that's not 6, F98, they have another, at the top of this page, they have an angle, and it has 40 degrees in the interior of it. Anything less than 90 degrees is an acute angle, so they label that acute underneath. Then they say your turn, and they give you 3 different examples of angles. There's one at the bottom of Braille page 98F, and in print it's at the bottom of your examples. In the your turn, it's labeled with the letter D. And in this angle, they give you an angle, and they say that it is 50 degrees in the interior of it. So you know 50 degrees is what kind of angle? It's an acute angle. And you could go through the next 2 examples. On the next page, you have G98, little letter E and little letter F. There are 2 angles on this page, one in the top half, one in the bottom half. One in the top half, find that angle and read on the interior of it. It should say 130 degrees. What's an angle called when it's greater than 90 degrees? It's an obese angle. It's an obtuse angle. Okay, obtuse. And then finally, little letter F. They give you another angle down at the bottom of G98, and in print it's to the right. Little F, and they tell you the measure of this particular angle is 75 degrees, and you know now any angles less than 90 degrees are called acute angles, cute little angles. So that's labeling angles. Important stuff to do in this particular section. Also a little bit of algebra link. So turn to H98. We're going to have an example 7. We're going to be given the measure of an angle, and we're going to have to solve for x. So this is just using some basic algebra. It says the measure of angle B is 138. Solve for x. So we find our tactile, find your drawing. It shows you have an angle. Gives you that it's 138 degrees. Let's practice our skills with labeling angles. We know that this is an obtuse angle. It's 188 degrees. But in the midst of it, it's saying that it's worth 5x minus 7. 5x minus 7. So angle B is 5x minus 7. If they gave us that angle B is 138, we can solve for x very simply using our algebra. It takes you through that process on the next Braille page. And in print, it says, explore. You know that the measure of angle B is 138. Therefore, the measure of angle B equals 5x minus 7. You're using your substitution property, right? Then you're using your addition property of equality by adding 7 to both sides. So we have 138 plus 7 equals 5x minus 7 plus 7. You're simplifying. 138 plus 7 equals 145. We have 5x left on the right side of our equation. Now we have to use our division property of equality, and we divide both sides by 5 to isolate x. And then x equals 29. Therefore, the value of x is 29. And you could check it by plugging 29 back into the equation, substituting 29 in for x. 5 times 29 minus 7 does equal 138. So we did it right. Okay. So you have a couple of problems like that just practice and refresh those basic algebra skills. The next pages take you through some constructions, and again I'm going to do construction videos separately to practice those skills. There'll be a series that I do that we'll work on separately with our compass and straight edge and draftsman. So you need to go to check your understanding and answer number 8 through 10, because that's going to just practice your skills at identifying angles and doing some basic algebra, right? And that's pretty much covers this section. If you would like more practice at that, you could also go to number 23 through 28 to practice identifying the measurements of angles. And then the algebra connection would be number 31. And that's the end of section 3-2. Not a whole lot of information there because we're going to do some supplemental videos to it. But some good stuff with acute, obtuse, right angles, how you label your measurements of your angles, and how you can do a little bit of algebra to make a simple expression equal to a measurement of an angle and then isolate the variable to solve for the value of that particular variable. So that's all we have for 3-2. We'll look forward to doing 3-3 very soon.